Hey guys, in this session we will see what is voltage division rule and its use with the help of a circuit. Welcome to the section. When we have series combination of elements, then the current through all the elements will be same, but the voltage across the elements are different. Now what is voltage divider or potential divider? It is also voltage divider is also called potential divider because all of you know that voltage is also known as potential difference. Okay, voltage divider circuits are used to produce different voltage levels from a common voltage source, but the current is same for all the components in a series circuit. Now, why it only works on series combination? Since the two resistors are connected in series, it must therefore follow that the same value of the electric current must flow through each resistive element of the circuit as it has nowhere else to go, thus providing a voltage drop across each resistive element. And also guys, please note that the voltage across the elements will be equally divided when equally valued elements are connected in series. At the end of this section, I will show you how the voltage is equally divided when equally valued resistors are connected in series with the help of a circuit. So we can calculate the voltage across individual elements using the voltage divide rule. The resistance of first resistor is R1 and the second resistor is R2. And the total voltage supplied is V, or we can say it as V in. Also guys, we can say that the current across R1 and R2 is same because it is a series circuit. I'm just calling the current as I here. Okay, the current flowing through R1 and R2 as I. That is the same current that is flowing from our voltage source. Consider this as a button cell or any other cell or battery or something. Okay guys, and in order to find the voltage across resistor R1 and resistor R2, we need to find the current. And for finding the current, we have our Ohm's law, that is voltage is equal to current into resistance. That is our total resistance, or we can say that the equivalent resistance. Okay, so we can write it as I is equal to V by R, that is voltage divided by resistance is current. And that is equal to, here you can see here, voltage by equivalent resistance. And in a previous video, I had already explained how to find the equivalent resistance of a circuit. Okay, and here the resistors are connected in series, so we can write it as R1 plus R2. So we can conclude that I is equal to V by R. Okay, and so we can say that the voltage across first resistor R1 is V1. I'm just calling it as V1, and the voltage across R2 as V2. Okay. Okay, so we can say that V1 is equal to I into R1, that is total current flowing through the circuit multiplied by that resistance itself, that is the resistance of that element itself, that is R1 here, and that is equal to, we can say that we had already find it, I is equal to V by R1 plus R2, that is equivalent resistance here, voltage by equivalent resistance is I, so we can write it as V by R1 plus R2 into R1, that is our resistance itself. So we can say that V1 is equal to V by R1 plus R2, that is the equivalent resistance, multiplied by R1. Like that, we can also say the V2 is equal to I into R2, that is equal to V by R1 plus R2 multiplied by R2. Okay guys, and for summarizing it, we got n resistors, and I want to find the resistance of a resistor R3. So the voltage across R3, I am just assuming it as V3, then V3 is equal to the total voltage supplied, that is V in, divided by R1 plus R2 plus etc. up to how many resistors you got in the circuit, you want to sum up there, multiplied by R3. And R3 is the resistance of that element itself, where we want to find the voltage across that. Okay guys, now I got two 220 ohm resistors in my hand and also a 12 volt battery supply. And now we can see how the voltage dividing is applied there. Okay guys, this is our circuit. Here I got two 220 ohm resistors connected in series. We can check its value using a multimeter. Okay, you can see here is 216. There is a small variation in the value, no issues. And the second resistor also, yeah, 216, no issues. And I got a battery pack of 19650 batteries. I got 3 batteries connected. Okay, and we can check its value. We will get approximately 12 values. So yeah guys, you can see here 12.16. There is a small variation there. No issues, we can check it here. Yeah, I'm connecting it to the common. Okay, I hope you understand the circuit. One end of the resistor is connected to positive and the other end is ground reference here. Okay guys, we can check the total voltage here. You can see it's 12.11. There will be a small or light variation there because some energy is dissipated as heat. Okay, now we can check the voltage across each resistor, that is R1 and R2 here. Okay, according to the law, we must get half of the supplied voltage, that is input voltage. Here we got 12 volt total, so we want to get approximately 6 voltage here. Okay, across each resistor, so we can check it. Yeah guys, you can see here it's 6.4 voltage and R2 is, yeah, it is also 6.4 or 6.5. So we got approximately half the voltage supplied. I hope you enjoyed this section guys. If so, please like this video and consider subscribing my channel. And if you have any doubts regarding this section, feel free to contact me. See you in the next video. Till then, bye.